welcome to video lesson number 4. Here we're going to be starting to learn about how to name compounds. We'll start with ionic compounds, and then in later videos we'll talk about molecular compounds. So first of all, ionic compounds, we want to remember that they contain a metal and a nonmetal, and it's the attraction between the positive and the negative charges that hold the compound together. In this first type, we're talking about binary ionic compounds. The word binary means two. So that means we're looking at two elements only in the compound. There are compounds that contain 3 or 4 multiple different types of elements in them, but we're going to start with naming compounds that only contain 2 elements, one metal and one nonmetal. We're also going to be starting with metals that only have one possible charge. So these are your alkali metals, your alkaline earth metals, aluminum and gallium are the ones that we will focus on. So remember, in your periodic table, the alkali metals and alkaline earth metals are the first 2 rows. So here we're looking at metals in row number 1, or column number 1 and column number 2, plus aluminum and gallium here, which both have a charge of 3+. So whenever you're naming a compound or writing the formula, the metal always goes first. So for the name or the formula, the metal always comes first. Okay, and that part, the metal, is the cation. So remember from our last lesson, the cation is a positive ion because the metal is going to be losing electrons. Then the nonmetal is going to be the anion, which has gained electrons to have a full outer shell and will have a negative charge. So the metal name comes first, and it's not changed in any way. So the metal name will always be written as per usual. The anion part, so the nonmetal, will have a slightly different name, okay? And so the way that we name the ions is we change the ending to "ide." So here we call these simple anions because they're a single element. So think of simple as being like sort of the basic possibility, so only one element. We will get into ions that are multiple elements, but here we're talking about simple ions, so only one element. We change the ending of the name to "ide." So if we look at example number 1, fluorine, okay, has the symbol F, the ion is F-, and we give it the name fluoride as the ion name. So chlorine, symbol is Cl. The charge on Cl is 1-. So if you're remembering back to your periodic table, okay, we can use the columns as a way of quickly figuring out what the charge on the ion will be. So for example, fluorine and chlorine, they're halogens. They have 7 valence electrons. And this means that they're all going to gain 1 electron to have a full valence shell. So all of the ions in this column will have a charge of 1-. Everything in the final column already has a stable octet because it has 8 valence electrons already. So these are all going to be neutral. They are not going to form ions. But your halogens have a charge of 1-. The next one over have 6 valence electrons, which means they need to gain 2. So they're all going to have a charge of 2-. Next one over, they have 5, so they're all going to gain 3-. When you have 4 out of 8, there's kind of a mix of things that can happen. So it could be 4 plus or minus, depending on what other compounds or other elements the things in that row are interacting with. So it can be kind of go either way, positive or minus. For your things in the next, sort of the first 3 columns, where they have 1 valence electron, 2 valence electrons, and 3 valence electrons, they're going to be losing electrons to get a full octet. So they're all going to have positive charges. So you might find it helpful to write your stable ion charges on your periodic table. So stable ion charges, I'm doing them in green. here. So 1 valence electron, which means that they're going to lose that 1 valence electron. So they're going to have an overall charge of 1 plus. Now you'll notice I'm just putting in a plus sign, and I did that the same with the halogens. I just wrote a negative sign. The reason we do that is in chemistry, we always want to write as little as possible while still being able to communicate what we're doing. So we don't write the 1 because it's assumed that if there's no 1 there, that it's 1. For the next column, they have 2 valence electrons, which means they're going to lose 2 electrons to have a full valence shell. These will have a charge of 2 plus. And in column number 3 here, these ones will have a charge of 3 plus because they're going to lose 3 electrons. So a quick review of that. So you can set that aside, but you will need it, so keep it close by. Back to our note here, chlorine, the ion, we change the INE ending to chloride. Everything else is written the same. Bromine has a symbol Br. It's also a halogen, has a charge of 1 minus. We would be calling that bromide. Iodine is the same. It's still in that halogen column. So it has a charge of 1 minus. It's iodide. Oxygen, symbol is O. Oxygen gets a charge of 2 minus. We call it oxide. Sulfur is just below oxygen on the periodic table. It also has a charge of 2 minus. We call it sulfide. You can write sulfur with a pH instead of an F. It doesn't really matter. Either way is fine. Nitrogen, okay, is in column number 5. It's going to gain 3 electrons. So it, as an ion, will be N3 minus. We call it nitride. And same for phosphorus. So P also has a charge of 3 minus, and we would call it phosphide. So now that we have a good idea of what simple ion names are, we can put these two things together. So your formula for how you're going to name these things, okay, so for naming binary ionic compounds, you give the name of the metal unchanged, and then the name of the non-metal with the ending "ide." So first couple examples, what is the name of the compound formed by magnesium and chlorine? We would get magnesium as the metal, so it stays the same, and it comes first. And then chlorine becomes chloride. So magnesium chloride is what we would call that. The second example, what is the name of the compound formed by calcium and oxygen? Calcium is the metal, so it comes first, and the name is the same. So calcium, oxygen becomes oxide. So calcium oxide. So that's how you write the name. The next thing we need to do is figure out how we write the formula. So we use formulas in chemistry to shorten things and make things nice and quick and easy to see. So when we're doing this, there's a bit of a sort of shortcut you can take. We've done this a little bit in our last lesson, but for that one we were drawing big diagrams, we were showing the transfer of electrons, and that can be a bit cumbersome, and you don't always want to have to do that. So we need sort of a shortcut to help us to be able to write the formula without having to do all of those steps every time. So your steps are written out here. I'm going to go through them in an example. So determine the formula of the compound formed by magnesium and chlorine. So we already know that this is called magnesium chloride. We just did that in part A of the previous page. And we could figure it out the long way, but we can do it also the short way. So first step is to write out your ion. So magnesium, looking on your periodic table, so keep this handy, is right here. Okay, it's in the second column. It's going to get an ion charge of 2 plus. And then chlorine, Cl, okay, has an ion charge of 1 minus. It's a halogen right there. And this is where the crisscross part comes in. So these represent charges. But when we bring them down, we crisscross the numbers we remove the symbol charges, the plus minus, and we bring the numbers down. So that brings us to Mg. This chlorine would be like a 1 minus, so it becomes a 1 with the magnesium, but the 1 we don't write, so we can just write it as Mg, and it's assumed that it's 1. And then Cl2, so the 2 from the magnesium here comes down, and we write it below to indicate the number of chlorine ions. So hopefully this is kind of reminding you a little bit of what you did in the last lesson. Let's do another one. Determine the formula compound of calcium and oxygen. Calcium has a stable ion charge of 2+. It's right below magnesium on the periodic table. And oxygen is in column number 6. It has a charge of 2-. So now we crisscross. That's going to give us Ca2O2. But the problem with this is, if you remember from the last lesson, that ionic compounds should always be written in their simplest form. So we need to reduce this to CaO, because a 2-to-2 ratio is equal to a 1-to-1 ratio. And in ionic compounds, the subscripts indicate the ratio of how many of each type is needed, not an exact number. So we always want to reduce to the simplest ratio. Okay, so a few quick notes on the bottom there. The subscripts, okay, the numbers need to be written down below. Sometimes people will write them up high, but they need to be written low. We don't write the number 1, so these are both 1, but we don't put ones in the formula. And the same with symbols, like we did with the chlorine, we didn't put a 1 beside it. Okay, and when you crisscross and bring the numbers down, you need to get rid of the symbols. So I'll put a little note in there. Okay, remove plus minus symbol. Just to remind ourselves that only the number comes down. You'll see that this 2 has nothing beside it. We got rid of that plus sign that was there. So you'll see on the next couple of pages that you've got some practice to do. So in page number 10, you can go through and do a bunch of practice questions. The answers to all of this page are linked in Edsby, and so you can check your work for the first page and make sure that you're doing it right. You can double check and just see if there's anything that doesn't make sense. You can let me know if you have any questions. For page 11, I haven't provided answers because I'm going to have you guys submit a picture of page 11 for me to review, check for participation, and give you any feedback that I'm noticing on it. So you'll complete page 4, okay, questions 4 and 5. So you have naming and writing the formulas, and then to submit a picture of page 11 to Edsby.